let's compute the limit of tangent x times sine of 1 over absolute value of x plus absolute value of y. So let us take a look at some elementary function like sine of 1 over x. Let's go back to elementary calculus. Look at the behavior of these types of functions. For example, you have sine of 1 over x. This is the behavior of the function around the origin, right? It's bounded between -1 and 1. And if you look at the sine of 1 over absolute value of x plus absolute value of y, this function behaves like this. It has a limited range. Let's go back to the board. Your sine is bounded between -1 and 1. Around the origin, you can actually find the upper bound and lower bound for this function. Very good. So now take a look at your tangent function. If tangent of x is positive, well, multiplying both sides by tangent of x doesn't change the inequality. Let me write down the tangent. Sine of 1 over absolute value of x plus absolute value of y less than equals to tangent of x. And then if you start take the limit of tangent is equal to 0, right? So the limit of negative tangent of x as x and y both goes to 0 less than equals to the limit of tangent of x sine of 1 over absolute value of x plus absolute value of y. X goes to 0, y goes to 0, which is less than equals to the limit of tangent of x as x goes to 0, y goes to 0. But these two are both 0. Am I right? So the squeeze theorem guarantees that the limit of this function must be equal to 0. Limit of tangent of x times sine of 1 over absolute value of x plus absolute value of y as x and y goes to 0, it is equal to 0. With the same argument, if the tangent is negative, so this is the first scenario, the second scenario, if your tangent of x is negative, well, if you multiply both sides by tangent, you have to flip the direction of your inequalities. Am I right? Well, what do we get instead? We get tangent of x less than equals to tangent of x times sine of 1 over absolute value of x plus absolute value of y less than equals to negative tangent of x. Now start taking the limit. Once you take the limit as x goes to 0, y goes to 0, limit x goes to 0, y goes to 0, and the limit here of negative tangent x as x goes to 0, y goes to 0, these two limits are equal to 0. So again, the squeeze theorem guarantees that the limit in this case is also 0. Again, remember that, for example, 2 is bounded between 1 and 4. If I multiply both sides by 2, I get 2 less than equals to 4 less than equals to 8. Multiply by 2, which is a positive number. But if you multiply by -2, you have to flip the inequality. You get -8 less than equals to -4 less than equals to -2. You have to flip the inequality. That's why when we multiply by negative tangent, we flip the inequality.